Alright. So let's look at the group 1 element. Ignoring hydrogen. So let's look at the alkali metals. This would be lithium, sodium, potassium, rubidium, cesium, and really, this one's really radioactive. Not much can be said about that. What do they all have in common? One valence electron. They all become +1 ions. Or cations. What are some common properties? Have you ever seen sodium and potassium? See if I can find a picture of sodium. So sodium, it's a soft metal. You can cut it with your with a butter knife. Very soft, silvery, oxidizes with air very quickly. Let's look up potassium. Elemental potassium. Alright, it's a soft, metallic, silvery, kind of dark as oxidizes with air. You can cut it with a knife. Let's look up elemental lithium. It's a soft metal. You can probably cut it with a knife. Reacts quickly with air and dulls. Let's look up rubidium. It's a soft metal, low melting point. Melt very easy, so can sodium and potassium. Cesium. Cesium is where we start to get different. You'll notice it changes color. It's now yellow, but for the most part, same as others. Let's look at what happens. See if I can find a video of it.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears.
It's oxygen reacting with it.
Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium.
Lithium and
the metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
So, that is the alkali metals. Let's write very reactive. Reactivity increases as you go down. So, because they all have the same number of valence electrons, they have very similar properties. This is why hydrogen is not included in this group sometimes, because hydrogen, when it mixes with water, doesn't have enough energy to react with it. If you put a fire, though, if you burn hydrogen, it will react with oxygen. It's just that you have to give it enough energy. As you go down the group, lithium has enough energy that if it encounters water or oxygen, it will react with it spontaneously. That's the reason why as soon as you cut it, you could immediately see it discolor or oxidize. Now, if you mix it with H2O, H2O isn't as stable as hydrogen and oxygen. Oxygen's very stable. This is slightly unstable. It's still stable. This is very stable. This is very stable. It's just that this is more stable, if you can think of it. When I say stable, I mean this has less energy being separated. Hydrogen, yeah. I know oxygen's very stable. So if you mix like lithium with this, lithium is going to want to react and form lithium hydroxide, and some hydrogen gas will be produced. Next, we have the alkaline earth metals. And this is your group 2A. So magnesium and calcium. If you ever looked at a diet supplement or vitamins, you'll notice that that anytime you need magnesium, you also need calcium. Anytime you need calcium, you need magnesium. These two chemicals are very similar. All the elements in this group is very similar. As we go down, due to mass changes, there is some differences. And energy holding the electron. We saw as we go down, they get more reactive. That's because why do they get more reactive as we go down? How do they react? They react by doing what? Hmm? Mm, they are one valence electron shells. They react by donating that electron to another atom. So when our molecule, and when we go down, which one holds more stronger? The one up holds on more stronger, while this one is very lazily holding on to that one electron. So remember that as we go down, they get bigger. So this electron, and we get more shielding because it's more easy able to give up this electron. As we go down, it reacts better. So let's see if we can come up with a nice set of rules. So as we go across a group, left to right, what increases and what decreases? So what all increases? Well, mass is going to increase. Number of valence electrons. Is valence, is it LA or LE? I think it's E. So mass increases, number of valence electrons increase. What else increases as we go to the right? ionization energy. And what else? Electronegativity. Which is also electron affinity. Non-metallic character. What decreases? That would be atomic radius. Metallic character. Uh, no, I would say so. Fluorine is the most reactive element. So it depends on whether or not it'll be a cation or an anion. So it should look something like this. It should decrease as you go to the right, but the moment you get to nitrogen, it should start increasing. So reactivity should look more like if this decreases as you go to the right, and then when you get to nitrogen, it should start increasing to fluorine. So lithium is very reactive. Beryllium isn't as much. Boron isn't. Carbon isn't reactive at all. So I should put carbon right here. Carbon is not very reactive. Then oxygen. So nitrogen is more reactive than carbon. Oxygen is very reactive. Fluorine is the most reactive. Boron is more reactive than carbon, and beryllium is more reactive than boron. So it looks like something like that. It's not a general trend. All right, what about going down a group? As we go down, I just realized I called this group. This should be period. As you go down a group. From top to bottom. So what increases? And what decreases? So mass, atomic radius. And I should have had also a what stays the same. What stays the same? That would be energy level. Number of energy level. Shielding effect. The number of internal electrons or inner electrons. So what increases is mass, atomic radius. Again, I'm not for sure on the. No, again, it's split between cations and anions. Cations act very differently than anions in reactivity. And I can't really say it's a periodic trend because it's different. So different there. So yes, metallic character. What decreases? Ionization energy decreases as we go down, which equivalently is electronegativity. Our electronegativity is equivalent to electron affinity. And so the opposite of metallic. Energy levels increases. Number of shells. Our number of energy levels. What stays the same? Yes, valence electron stays the same. We can add as we go to the right, nucleus strength. Because shielding doesn't change. I'm not going to add it down here because shielding effect does change. I would say the shielding effect increases down here. So looking at the periodic table, everything in this column has one valence electron. And they form +1 ions. Everything in this one has two valence. And they form +2 ions. Everything in the boron group, or boron family, has 3 valence and forms +3. These have 4 valence. These have 5 valence and forms -3 ions. This has 6 valence and forms -2 ions. And everything in this one is 7 valence and has -1 ions. And this one has non-reactive, inert, or zero, or neutral. They have 8 valence. What do all of the transition metals have in common? What block is this? when looking at the periodic table. It's the D block. This is the S block. And these over here is the P block. So transition metals are in the form of S2DX. The S block ones are in the form of SX. And the P block is in the form of S2, D10, and PX. So if you see 6S, D10, P6, and so 4S2, 3D10, 4P6, this should tell you because it has a P in it. This is in the P block section. And counting the highest energy level, it has 8 valence. And is thus a noble gas. If you just see S2D10, D something, so S2D10, that's transition. If you see S2D3, that's also transition. If you don't see any P. On the test, there are some configurations like this. Again, we've already covered electron configuration. It's not too much. So, a transition element has a partially filled D sublevel. Unless it's on this one. This one has it completely full, but no P block. So, transition metal. Alright, so say having a partially full D block means you're a transition metal. Having only S block and D block also means, but no P block also means transition metal. And I ask a lot of how many valence electrons does something have? So sulfur, how many valence electrons does sulfur have? 6. Which atoms become cations, meaning positive ions? Obviously, it'd be these. And this one may or may not include this one. And which ones become negative ions? So these would be your anions. So which is bigger? Nitrogen as an atom Our nitrogen is an ion. So it's going to gain 3 electrons and get bigger. It's an anion. Anions get bigger when they gain electrons. Cations get smaller when they lose their electrons. Lots of questions of the form of which of the following has the largest atomic radius? Which of the following has the highest first ionization energy? Order the following in order of decreasing atomic radii. Given a blank table, this is your group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 group, 14 group, 15 group, 16 group, 17 group, and 18 group. I do not give group numbers, but you should, whenever I refer to group 13, should know what group I'm talking about. Group 13 is the boron group. You just literally name it. If I'm talking about the A group, then basically you just put an A by all the numbers. If it's greater than 10, you can drop the 1 in front of it. 3A, 4A, 5A. It just happens to work out, the universe did, such that this 13 corresponds to 3A. If you see a mistake, or if you see me ask group 5, ask a question, because it's very concerning. I do not ask questions about groups of transition elements. Usually. I probably meant 5A. So there's random questions, like I said, in group 13, which has the highest electronegativity. Boron, aluminum, gallium, or indium, which is which has the highest electronegativity. Group 13. Yep. Boron, as you go up, increases. You should understand why atomic radius decreases. As you go to the right, shielding effect stays constant, but the nucleus strength increases. As you go down, the shielding effect increases, and the radius gets bigger. I'll also ask potassium and calcium. Which one is smaller radius and why? By the way, let me skip ahead. It's all multiple guess. So one possible choice would be potassium is smaller. You should immediately cross it out because you know calcium is smaller. And there'll be 2 questions saying calcium smaller because it has higher number of energy levels. That's wrong. They have everything on the same row has the same number of energy levels. Calcium is smaller because the shielding effect stays the same and the increase in nucleus strength charge increases. Your only source of notes is going to be a blank piece of paper or blank periodic table. I'm going to remove this from the back. So do not rely on the fact that electronegativity was given on your copy. You will only have a blank periodic table. I'm trying to see if there's any questions I have not gone over. I'm fairly sure I've gone over everything. So what's a row called? A row is called a period. And a column is a group. Atoms in the same group have the same number of valence electrons. Noble gases, they don't react. What is group 7 called? The fluorine group. What is our fluorine family? What's the name that it normally goes by? Halogens. Halogens is a name that is used quite a bit to refer to them. So, fluorine, very toxic, don't want to breathe it in. Chlorine, very toxic, don't want to breathe it in. Bromine, extremely toxic, don't want to breathe it in. Fluorine is the most toxic. So, if you breathe in pure, in World War II, the Nazis used pure chlorine as a chemical weapon. What chlorine does is it mixes with water to form hydrochloric acid in your lungs. The hydrochloric acid begins dissolving your lung tissue, causing you unable to breathe, cough, or very painful death. Fluorine produces hydrofluoric acid. Hydrofluoric acid will attack your bones and the calcium in your bones specifically, and it also destroys your nerve endings. Which means if you get a drop on your finger, you won't feel it, but it'll sink into your bones, and your bones will be dissolving. Which initially you won't feel it, but I heard it's a extremely painful way to die. You won't realize it at the time. What does it mean by the energy required to remove the outermost electron? Mm-hmm. Uh, in the halogen group, which one has a tendency to gain electrons the most? This is electron affinity, but again, you could basically treat it as electronegativity. That'd be fluorine. Fluorine wants an electron more than anyone. Has the greatest tendency to gain electrons. Has the greatest attraction to electrons. Oh, there is something I finally found that I didn't really cover. And yeah, I did cover it. Non-metals. What are some properties of non-metals? They have high electronegativity, right? What about ionization energy? They have high ionization energy, which means they like to steal electrons and form molecules. While metals have the opposite, low En and low ionization energy. They like to keep to themselves and share their electrons. As long as a non-metal doesn't come and steal some electrons from metals, metals usually aren't very reactive. At least amongst themselves. What are they doing over there? Is everyone going to be here tomorrow and the next day? I think tomorrow I'll do Kahoot. And then we'll have a test Thursday. Alright, bot. Put like students from other classrooms. Ninth graders. I'll put ninth graders. But that's basically the test. Yeah, we'll do that. I want to grade y'all's homework and pass it back tomorrow. Which means someone needs to get me a copy of it. The homework I said I really wanted today. Uh, try to get it quickly. You guys and y'all's inability to do puzzles. Y'all ever taken an IQ test? IQ test is a measure of general intelligence, and if you've ever taken one, it's usually puzzle solving. There's no words on it until you get to like the language section. Um, Let me show you. No, so here's a question from a real IQ test. What goes into the blank bottom right? It's taking y'all way too long to answer this. We'll go into the blank, the square at the bottom right.
Pattern that I recognize.
What's the pattern?
Oh, little mirror.
Yes. Why?
I looked at it.
Mm,
It mirrors to the right and it mirrors down. Talk to it, but then I confused myself. I was like, if it was that pattern, I would think.
do you understand it? It's rotating clockwise. Top left, top right, bottom right. The top one is in the shape of a square. The middle one is in the shape of a circle and rotates clockwise. The bottom row is the shape of a square slanted, a diamond shape, and it starts on the left and rotates clockwise. This problem would have been what places you in probably 4th grade. So you could argue that there was some logic in it.
I saw that the bottom one was